Hello everyone, welcome to my class. So this is me, Praveen Chobe. I am going to teach you a very important topic from climatology. And the name of the topic is geostrophic wind. So this is topic from climatology. As you know, climatology is one of the important part of physical geography. And in physical geography, we are dealing with a topic called geostrophic wind. Okay, so we'll try to understand what is this geostrophic wind, as this concept is given in your NCERT also. And this is the most important question maybe UPSC will ask you in next exam. Okay, they can ask you a question in mains exam also in GS paper 1. So let's understand the entire what is geostrophic wind. Okay, now first of all we have to understand the concept what is wind. So wind is, we can define a wind as a horizontal movement of air. So when we call horizontal movement of air is called wind. Now what is the reason behind for origin of wind? So reason is very simple here, a pressure difference. Okay. Now we can define here the wind is the movement of air caused by difference in air pressure in our atmosphere. So in our atmosphere what we know, land and water. If we take an example, so land, land easily get heated during a daytime and water takes time to become hot. Okay, so once a land will become hot, what will happen, a pressure over the land is developed is a low pressure and over the water will be a high pressure. So why low pressure and high pressure? This is a very basic concept, because here the wind is rising. So the place where a wind is rising, or we can say air is rising, that create a low pressure, and the place where a wind is sinking and that's a descending, that's create a high pressure. And wind is always blowing from high pressure to low pressure. Okay, now the one reason behind for origin of wind is difference in pressure. Okay, so wind will be here in this case will be blow from high pressure to low pressure, from the water to a land. Now this is clear what is wind. Now once a wind is blowing, it is affected and we can say it modified by three important forces. What are the three important forces? The first is your pressure gradient force. Okay, we'll try to understand what is pressure gradient force. Then second one is your Coriolis force. Again, very important concept in climatology, because Coriolis force will help you to understand the entire wind system. Okay. Then third force is called a frictional force. We will cover all these three force one by one, and then we'll try to understand what is exactly a geostrophic wind. Okay, so let's move to the next slide, and in next slide we'll try to understand a pressure gradient force. What is pressure gradient force? So we already know atmospheric pressure. Okay, because of concept, we know the concept of low pressure and high pressure. Okay, now pressure gradient, the word pressure gradient first of all will define. So change in pressure measured across a given distance is called a pressure gradient. Pressure gradient means when a place, suppose this is the place A and this is the place B, and this place A is, suppose the pressure is 120 MB, millibar is the unit of the measuring the pressure, and place B have pressure is suppose 900 MB. So we can say place A have high pressure and place B have a low pressure. Now this is the change in pressure from A to B is called a pressure gradient. If pressure is changing it more faster rate, okay, that create a force, and that net force is applying between high pressure to low pressure, and this force is called a pressure gradient force. Now what is this pressure gradient force? Pressure gradient result in a net force that is directed from high to low pressure, and this force is called a pressure gradient force. Okay, now remember one thing, this pressure gradient force is responsible for the movement of air. If the change in pressure is happen in more faster rate, the speed of the wind will be a more. If the pressure gradient force is low, it means the changing of pressure from A to B is not as higher at higher rate, that cause a wind to blow in a slower rate. Okay, the pressure gradient force is responsible for triggering the initial movement of air. So in exam, in prelims exam, they can ask you which of the following statement is correct about the pressure gradient force. So remember, this is a force which is responsible between a high pressure to low pressure. How the wind is changing, how the pressure is changing from high to low pressure, it create a force that's called a pressure gradient force. And this is the responsible, and when say we can say it's a triggering effect of initial movement of air. Now after the understanding of the pressure gradient force, we'll move to the understand what is Coriolis force. Most of important force. What is this Coriolis force? Now remember, Coriolis force is not a real force. It just, we can say, it is result of the earth rotation. It's just the effect of rotation of the earth. Okay, force, simple language we know in physics, force is about push or pull. But here nothing is push, nothing is pull. Here it because of the rotation of the earth. As you know, the means one motion of the earth is called rotation. As our earth rotate on the axis from west to east direction, because of this rotation, whatever an object which is in a motion and not directly attached to the earth surface, it deflects its direction. The direction is changing. Okay, and because of this changing of direction, we called as Coriolis effect, or we can say effect of that wind is changing a direction because of rotation of the earth. Now this famous force is discovered by a scientist called Gaspard G. Coriolis. He was a French civil engineer. Okay, so remember the name of this scientist who discovered, who was the first time who discovered the means this type of force, and how the wind is changing its direction, okay, in both northern and southern hemisphere because of the rotation of the earth. Okay, now most important thing is what rotation. Okay, where a wind is changing direction, in what rotation. So first we have to understand the wind deflect a direction because of this rotation of the earth. Whatever the wind which is in a motion, it deflect the directions. Okay, and direction in the like northern hemisphere. Okay, northern hemisphere, the wind will deflect right hand side, and in southern hemisphere wind will deflect left hand side. This is very important. And remember, for exam point of view, exam mein pucha ja sakta hai aapse, they can ask you a question, what is the direction of deflection of the wind. So this is the right hand side in northern hemisphere, left hand side in southern hemisphere. This is what you must be remember. Okay, any object which is in a motion, okay, it's not only a wind, even like a wind, like wind, birds are also flying, aeroplane, ballistic missile, even a ocean current, every, okay, every object which is in motion not directly attached to the earth surface, it's changed its direction. And direction is like in northern hemisphere, as you see in this diagram, in an animated diagram, how the wind is changing its direction. So if in simple language we can say, if a wind is present in northern hemisphere, suppose the wind is moving in from equator toward the pole, so in this case wind will be deflect right hand side. How you can define a right hand side and left hand side? You have to stand behind the wind, and your left hand side is the left hand side of the wind, your right hand side is the right hand side of the wind. Similarly, in northern hemisphere, as you see, wind is deflected right hand side, and in southern hemisphere, when the wind is blowing from equator toward the pole, it deflect left hand side. You can stand behind the wind, so your left hand side is the left hand side of the wind, and we can say left hand side. In southern hemisphere, wind is deflecting left hand side. Now one thing is must be clear, whatever the direction of wind, it's not only from north to pole or pole to south. Okay, whatever, if wind is moving from east to west, from west to east, it will deflect right hand side. Okay, if wind is moving from, suppose, east to west, okay, it's moving from east to west, it can deflect, okay, again it deflect in right hand side. So remember, direction of the wind is changed in northern and southern hemisphere, and this is what left hand side in southern hemisphere, and northern side it is a right hand side. Okay, so remember this thing. Now Coriolis effect wind. Okay, what is other features of the Coriolis effect, we will try to understand here. So Coriolis affect the wind direction, not the speed of the wind. Very confusing statement. They can create give you, ask you question, which of the following statement is correct about the Coriolis force. Remember, only direction of the wind is changed. There is no any change in the speed of the wind. Okay, the speed of the wind will remain the same. Wind, if wind is blowing more faster, okay, deflection will be happen more faster. And this is the formula you should remember. Cf is equal to mb sine theta. Okay, so what is here? M is the mass of the body, v is the velocity of the wind, and theta is the angular distance. As on the surface of the earth, as you know, this is the equator. Okay, 0-degree equator. So if you want to calculate what will the direction of wind at 10-degree north, okay, then 20-degree north, okay, if you want to know what is the direction of the wind, how the Coriolis force will be at 80-degree, or what will the Coriolis force at the 90-degree north pole. Okay, so remember, this formula is saying that sine 0-degree, okay, sine 0-degree is always value remain a 0. okay, and sine 90 degree, because if you will apply the formula, then CF is equal to, if you want to know what is the Coriolis force at the equator, it will be mb sine 0 degree, and we know sine 0 degree is 0, so entire equation will become 0. So Coriolis force at the equator will be a 0. If you want to know what is the Coriolis force at the pole, so it a formula will like mb sine 90 degree, and sine 90 degree is equal to 1. So this will be a Coriolis force will be a 1. Okay, so Coriolis force is vary between 0 to 1. So it will be maximum at the pole and minimum at the equator. Remember these things. So Coriolis force will 0 at the equator, and sine theta is equal to 90 degree. So it will be maximum at the pole. Maybe they can ask you a question and you must be know the answer, okay, because these things are very basic things. Okay, now wind blow anti-clockwise in northern hemisphere, wind blow clockwise in southern hemisphere. If they will ask you why cyclone flow, why cyclone is blow anti-clockwise in northern hemisphere and it clockwise in southern hemisphere, this is also happened because of the Coriolis force. Each and every movement of air, you will know there is some reason behind for Coriolis force. Okay, because of this Coriolis force, we see a different things, like cyclones are not formed near the equator because of Coriolis force is 0. Cyclone is always formed 5 degree north to 5 degree south beyond. This is the range of the formation of cyclone and tropical cyclone. And in formation of tropical cyclone, Coriolis force is one of the important factor. Second important thing is Coriolis force always at right angle to the horizontal moving of air and other moving objects. Suppose this is the blue line indicate the movement of the wind, then it's black, okay, black arrow is called Coriolis force. It always make an angle of 90 degree, okay, whatever be the direction of the Coriolis force always make a angle 90 degree. If this is the wind direction, then Coriolis force will be always act making a 90 degree angle. Remember this, these are some basic concept about the Coriolis force. Okay, now what are the significance of the Coriolis force? Because we are dealing with the Coriolis force, we should know why it is important to study Coriolis force. First is trade wind. As you see, the name is called northeast trade wind, southeast trade wind in, okay, in planetary winds. If this is a 0 degree equator, okay, this is the subtropical high pressure belt, subtropical high pressure belt, okay, and this is the subtropical high pressure belt in your southern hemisphere, and this is equatorial low pressure belt. So whatever you see the northeast trade wind here, okay, northeast trade wind, southeast trade wind, these trade winds are basically a change in direction because of the trade winds. Even a westerly subpolar low pressure belt, and here a polar high. So whatever wind you see, this all type of wind on the surface of the earth is changing its direction because of the Coriolis force. And this is northern hemisphere is in northern hemisphere right hand side, and southern hemisphere it is in a left hand side. Okay, westerlies and polarlies are to cyclone genesis, even the ocean currents. Okay, ocean currents ka formation, that's also happened because a ocean current change the direction is also because of the Coriolis force. And most important is geodynamo effect. It is about the Earth's magnetism. It is about the Earth magnetic property. As in outer core, as you know, outer core is in liquid state. So outer core is how the molten materials are moving, and this also affect because of the Coriolis force, and that's create electron and magnetic field, result in the formation of magnetism of the Earth. So geodynamo effect is also happened. This is also happened because of the Coriolis force. Okay, this is very important to know in exam point of view. Now, the third important force we are trying to understand is frictional force. What is this frictional force? So, you know the basic concept of frictional force. Friction, whenever the earth surface is very, okay, undulating earth surface, okay, it's like a mountain hills. So, in this case, when the wind is blowing, it always changes its direction. There is a decrease in speed of the wind. There is change in direction of the wind because of this Coriolis force. But our concept here is we are going to study a geostrophic wind. We are talking about a wind which is blowing at the height of 8 to 10 kilometer above the earth's surface. Okay, so you know 8 to 10 kilometers in such a great height, there is no any relief features present on the surface of the earth. If only the Mount Everest is present. Okay, apart from Mount Everest, such a high relief features, long relief feature is not exist on the earth's surface. Now the frictional force is created by the imperfection of the earth's surface, which provide resistance to wind movement. Okay, so it will provide the resistance of wind movement. It will decrease the speed of the wind. It will change the direction of the wind also. Okay, and one thing always remember, this frictional force is always acting opposite to pressure gradient force. Okay, this is called a frictional force, and this acting opposite to the pressure gradient force. So it has an impact on a wind speed also. So it influences the greatest near the surface and often extend up to the height of 1 to 3 kilometer above the surface of the earth. Beyond the 3 kilometer, it's completely absent. Okay, the friction on the sea surface is negligible because sea surface is a completely plain area, so there is a friction is very negligible. Or uneven terrain, like I said here, undulating land surface where you see land, mountains, valleys are present. The wind direction produces large angles with isobars, due to which friction and the wind is slowed. Okay, we'll also talk about the isobar. Isobar is an imaginary line that joining a two places have equal pressure. Okay, now that we are here to discuss our most important concept here, what exactly the geostrophic wind. Okay, we are talking about the wind which is blowing at the height of more than 2-3 kilometer, or we consider as the height of 6 to 8 kilometer above the earth's surface. So remember, when we talk about the 6 to 8 kilometer above the earth's surface, this wind is free from this third important factor called frictional force. And this wind will be only affected by two type of force called pressure gradient force and Coriolis force. Okay, so remember, a geostrophic wind is only affected by two type of force, pressure gradient force and Coriolis force. Okay, now wind in the upper atmosphere, that is 2-3 kilometer above the surface, are free from frictional effect of the surface and controlled by the pressure gradient and Coriolis force. Okay, so this is what we called as a parallel line is called isobar. So isobar, you know, isobar are those lines which joining the place having equal pressure. Now this is the high pressure area and this is the low pressure area. Now obviously the wind will be blow from high pressure to a low pressure. Okay, so air parcel initially at the rest will move from high pressure to low pressure because of this pressure gradient force. This is the initial factor, and we can say triggering factor that cause the initial movement of the wind. So once the wind will start to move, I said if the pressure is changing at the faster rate, the speed of the wind will be more. If the speed of the wind will be more, it means because of the Coriolis effect, it deflection will be also more. Okay, so this diagram is very important, that give you an idea. Then we understand here, once the wind is start to blowing from high pressure to low pressure, it deflected by the Coriolis force. Okay, Coriolis force in the right in the northern hemisphere or left in the southern hemisphere, as per the property of the Coriolis force. As the wind gain speed, the deflection increases. Okay, this is how pressure gain force, high pressure here and low pressure here. So wind is further rising. Okay, this is the Coriolis force which acted always perpendicular. Now this is the direction of the wind, because once the speed of the wind will be increases, it continuously means it will be deflected, and it will be deflected. Suppose this is the diagram showing a northern hemisphere. So in northern hemisphere, deflected in a right hand side. Okay, right hand side, and continuously it will be deflect. Okay, at this point, a wind will blowing once one time will become when the wind is finally blowing parallel to, this is what line, this horizontal line is called isobars. Okay, parallel to the isobars, and both the pressure gradient force and Coriolis force are acting opposite to each other. It means this is the, if this is the wind is blowing, okay, this is the isobar, then the, if the, this is the pressure, this is the, my neck, by this finger represent you, this is my finger represent you direction of the wind, and this two opposite side of the plane is, one you can say a Coriolis force, another one is a pressure gradient force. They are acting opposite to each other, and in this case the resultant wind is blowing parallel to the isobar, and this wind is called a geostrophic wind. So at this point, the wind will be blowing parallel to the isobar, perpendicular to the isobar, perpendicular to the pressure gradient force. Okay, and when this happens, the wind is referred to as geostrophic wind. Okay, this is what a geostrophic wind. So as the once the wind start moving from high pressure to low pressure, a deflection will be happen, and once it will be deflected, and wind will become parallel to the isobar, and both pressure gradient force and Coriolis force will be acting opposite to each other, and that result in the formation of geostrophic wind. Okay, thank you. I hope this video will help you to understand a better geostrophic wind. Thank you everyone.